Hello and welcome. We are Team Hackiitg. In this video, we will be taking an introductory look at network and asset discovery monitoring tools and how it helps enterprises to keep their network operation at their fullest capacity. Enterprise networks are becoming more and more complex every day. In order to meet the rising need and demand for the digital business solutions, a business needs to ensure that its network is performing at the speed and efficiency required for it. Network monitoring is the use of a system that constantly monitors the computer network for slow or falling components and that notifies the network administrator in case of outages and issues. In more practical terms, the network monitor is either a piece of hardware or software that continuously observes your network and data that flows through it, depending on how the monitoring solution actually functions. It may capture data directly from the network as it passes by, or it collects data stored from the network node. And the monitor that interprets this data and displays it via dashboard on your device, allowing you to visualize your network performance. If this program detects any issues with the network or signs that might indicate a potential for the network failure, it will alert you or your IT team to the problem and get and fix your solution. So now we will introduce you with our Kibana local dashboard system. So we have generated our CSV using the Python script and that is ran over our local system. This CSV script is processed using Python and we have generated a final CSV and which is uploaded to the Kibana system. So Elastic Database Search System has been used and Kibana is used to display the dataset. So the first table represents workgroup versus IP. Now it shows all of the different work groups that are represented and mapped to all of the different IPs available. Now next, there are different work groups at different timestamps available and shown in this vertical bar chart. There are total number of 12 active directories, there are 12 unique IP addresses and MAC addresses, and with total number of 3 work groups available and shown here with a number metric system. Now next, there is active directory with respect to timestamps that is shown here. Now next, we have shown using a table that is how many work groups and how many count of active directories are displayed over each of the following. Now next, we have displayed work groups versus timestamps shown as follows. Now next, we have used a pie chart to display which operating system and work groups are interlinked together to display our best of the data output. Now we will discover and introduce you with our Kibana remote scanning dashboard system. So first of all, it shows all of the details taken from our CSV data. So at first it shows the distribution of operating systems, then it shows their total number of IPs or unique IPs available, then it shows that on and off IP counts in our operating system or in our remote network system, then it shows that status of IP shown as percentage GOS, like we know how many IPs are switched on or how many IPs are switched off. Now it shows IP versus workgroup diagram, then it shows us the OS versus IPs, then it shows us the MAC address versus the different work groups as shown in this figure. These information are very much vital for us to deal with our information and to dig further information related to this. Workgroups resource allocation is shown now in this corner. Now it shows that there are total number of 17 unique operating system in this remote network. There are total of 17 unique active directories available, 4 unique device types are available, 9 unique domains are available. Then we have shown with a tree map of different operating system in our workgroup. Then we have shown that with the help of bar graph, workgroup versus device, then shows that there are total number of 6 unique services, there are total number of 6 unique versions that are used for a particular IP. Now we have stated and shown using the pie chart that how many versions versus records are shown. Then we have used to display what are the frameworks or operating systems are shown here. Then we have used a format to display services that has been used here. Now we have used a particular format for separate IP system to display which are the ports that were open there and what were the usage or versions of those ports and what all services are running on those ports specifically. This helped us to display the remote scanning system perfectly and to help us to visualize it more perfectly.
So now we are going to start with SSH tunneling. So first I logged into the remote server, then used turnctl command to create a virtual interface named tab0. Then I used ifconfig command to assign the virtual interface a IP address. Then did the same on my local system. Then I used SSH commands -o flag -o tunnel equals to Ethernet so that I can route my whole traffic through that tunnel. Then I ran the ARP scan on that interface tab0 on my local machine and it showed that it had connected to my remote server through that virtual interface. Then I used ETH tool to confirm that it had connected, as it shows that link has been detected. Now I am gonna use net masquerading to forward my whole traffic on this subnet to the remote network. So these are the commands I use to complete the net masquerading on my remote server. Then I am gonna run IP route aid command on my local machine to inform the local machine to route any traffic going on those IPs to that network interface, that IP. Now then I ran the command nmap-sn and that remote server and its subnet, so that I can confirm that we can scan on the remote network using SSH tunnel. And as you can see, we have successfully done it. Now we are going to show a network scan using Python automated scripts. As you can see, we are using ARP scan for detecting local active IPs and then further scanning those IPs using nmap and getting all the information we need and then storing them in CSV files. So, and we are running that script as sudo because ARP scan requires sudo access. Then we store all the data we recovered in CSV files. Now, for remote network, first we tunnel our whole traffic using SSH as we have shown that earlier. Then using nmaps-sn flag, we detect all the current active IPs and then scan them further using other flags like -sc, -sv, and for detecting OS using -o, and further investigate the network and store the whole those data into CSV files. Thank you.